All right, Kipsters, in the last week and a half, we've been solving for x. We are finding our answers. We are now going to be changing our vocabulary. We are now going to be calling them solutions. We'll make the statement true, and there's actually 3 different types of solutions that we will be seeing throughout algebra. And the 3 types of solutions are unique solutions, no solution, and infinitely many solutions. As a matter of fact, you actually already know 2 of them. We are going to be looking at our do now problems to see if it's a unique solution, no solution, or infinitely many solutions. So let's first take a look at that very first problem. I even wrote it underneath, which is 7x minus 3 is equal to 5x plus 5. And we know the answer is 4. The number 4 will make both sides equal each other. Since it's only one answer, that is actually a unique solution. As a matter of fact, we could actually automatically know it's a unique solution by looking at the original problem. So I have 7x minus 3 is equal to 5x plus 5. The very first thing I want to do in any of my problems that is asking me to classify is look at the coefficients of the problems. So I'm going to look for the coefficients. Remember, the coefficient is the number that is in front of my x value. I have 7x and I have 5x. So I'm letting you know right now, if my coefficients are not the same, if they are different, then it's going to be a unique solution. So I want to write that out. So I wrote down my sentence, and my sentence does say it is a unique solution because they have different coefficients. So if I realize that they have different coefficients, so the number that is in front of the x value, it is going to be a unique solution, which means I only will have one answer that will make the statement true. So that means I don't really need to solve for these problems. So let's take a look at my second problem. So we already automatically know it's no solutions. We're going to be looking at the problem. We're not going to be solving for it because I'm going to give you some characteristics to already let you know that it's going to be classified as a no solution. We are still going to be looking for our coefficients on each side. I see my coefficient is this 7x and this 7x. I want you to keep that in mind. And then as soon as I notice that they have the same coefficients, I want to notice their constant. I have a negative 3 as a constant and this positive 5 as a constant. The way you know it's a no solution by looking at a problem that is simplified on both sides is if they have the same coefficients but different constants, then it's going to be a no solution. So it is going to give me a false statement like we did up here as our problem. We said negative 3 is equal to 5, which is a false statement. Infinite many solution means the statement will always be true no matter what. So as you can tell, negative 3 is equal to negative 3. That is a true statement. If it's a true statement, that is actually means it's going to be infinitely many solutions. Just to look at the problem, we first need to make sure it is simplified on both sides. So I'm going to look first my coefficients. I notice that my coefficient is 7x on one side and a positive 7x on the other side. All right, they're the same. And then I want to notice my constants. And my constant is this negative 3 and this negative 3. Wow, I just realized they have the exact same thing on each side. So for my answer, I'm going to say it is infinite many solutions because my coefficients and my constants are the same. So today we are not necessarily solving unless it's to simplify each side. Remember, I want to make sure I have a coefficient and a constant on each side, and I want to make sure I am classifying on what type of solutions. We learned about 3 different types of solutions. We learned about unique, no solutions, and infinitely many solutions. Unique solution is one answer will make it true. And the way I could see it, if my coefficients are different, then it's going to be a unique solution. If it's no solutions, then my coefficients are the same, but my constants are different. If it's infinitely many solutions, they have the exact same variables on each side. So that means I need to have the same coefficients and the same constants on each side.